Given the polynomial function y equals f of x below, graph y equals the absolute value of f of x and y equals f of the absolute value of x on the same grid. For y equals the absolute value of f of x, keep all of the x values unchanged. For portions of the graph for which y is greater than or equal to 0, leave these unchanged. For portions of the graph where y is less than 0, reflect the graph across the x-axis. This will make all of the negative y values positive. For y equals f of the absolute value of x, the portion of the graph for which x is greater than or equal to 0 is unchanged. This corresponds to any portion of the graph to the right of the y-axis. For the portion of the graph for which x is negative, this is to the left of the y-axis, reflect the portion for which x is greater than 0 across the y-axis. Since x is within an absolute value symbol, f of x should be then equal to f of negative x. This means that the y-axis corresponds to an axis of symmetry for this graph. First of all, for y equals the absolute value of f of x. Here, we're going to be looking for points where the y value is negative. The first one here corresponds to an x value of negative 2. Note that if x is negative 2, for the original function, the y value is negative 4. This means that for the absolute value function, if x is negative 2, then y is positive 4. The other portion of the graph for which the y values are negative are between x equals 2 and x equals 4. The minimum y value corresponds to an x value of approximately 3.2. At this point, the y value is approximately negative 1.6. This means that an x value of about 3.2, the y value would have to be positive 1.6. Note that the portions of the graph that are already above the x-axis remain unchanged. Those portions below the x-axis get reflected through the x-axis and become positive y values. We then get the graph here that's given in red. Next, for y equals f of the absolute value of x, here we'll be looking at the right side of the graph and simply reflecting it across the y-axis. At an x value of 1, the y value is also equal to 1. This means that for x equals negative 1, we would also have y equals 1. At an x value of approximately 3.2, note that the y value for the original graph given in blue is approximately negative 1.6. This means that for an x value of approximately negative 3.2, the y value will also be approximately negative 1.6. We'll use one more point to get this graph as accurate as we can. Note that if x is equal to approximately 4.5, the y value is also approximately 4.5. This means that for an x value of negative 4.5, the y value will also be approximately 4.5. Now recall that to the right side of the y-axis, the graph remains unchanged. This corresponds then to this green portion. To the left of the y-axis, it will be a reflection across the y-axis. So the other portion of the graph is as shown here.